All right, so if I'm doing the same thing for a double displacement reaction, remember a lot of reactions fall under this double displacement. So double displacement reactions, just writing it up here again, we're saying AB plus CD is going to give me AD plus CB. So this is the scheme for it. A lot of reactions fall under this: the precipitation reactions, the gas evolution reactions, the acid-base reactions. They all pretty much fall under this double displacement scheme. So let's say I have nickel 3 chloride. So let's say I have nickel 3 chloride, looks like this, plus potassium phosphate, which looks like this. All right, so if I look at this, my A is nickel, my B is chlorine or chloride, my potassium is my C, the phosphate ion is my D. I'm going to just follow the scheme where I'm going to switch my A and my C. So now my A and my D are going to go together, which is nickel and phosphate. But when I do that, I still have to remember to write the correct formula. So when I go to write the correct formula, this is nickel 3, and I know it's nickel 3 because this is a 3 right here. So I'm now saying nickel 3 is going to go with the phosphate ion, and the phosphate ion has a charge of 3 minus, so it's like 3 plus and 3 minus go together. I'm going to be left with nickel 3 phosphate. The formula looks like this. And then my C and B are going to go together. So my potassium and my chloride are going to go together. And in this case, I'm going to be left with potassiums in group 1, chlorines in group 7. So that's +1, -1. I'm going to be left with KCl. And I know potassium ions and chlorine ions are aqueous just from reading the solubility table. And I know that phosphates are pretty much going to form solids, and that's from reading the solubility table. And just in case you're confused on what I'm talking about, remember you have to look at the solubility rules, which will be given to you on the exam. But let me just pull them out again for you. Remember, we have the solubility rules. This table is listed on the exam, but when you look at phosphate, mostly forms a solid unless it's paired with lithium, sodium, potassium, or ammonium. Potassium is going to form aqueous solutions, no exceptions. All right, so this is considered my molecular equation. Remember, my A and my C switch places. So now I'm left with A and D, and then C and B. All right, so when I go to write my complete ionic equation, well, let me make sure this is balanced. So we definitely have to make sure this is balanced first. So if I go through and balance this, I'm going to say 1 nickel, 3 chlorines. So what do you guys think I need to do to get chlorine happy on the other side?
Potash. It's not balanced.
It's not balanced. So I'm saying I
You
have,
added 3.
yeah,
Potash.
I'm going to put a 3 right here in front of the potassium chloride. And now I see I have 3 potassiums, 1 phosphate, 1 phosphate. Like I said, double displacement reactions easy to balance. So this is the molecular equation. Let me write that up here. Molecular equation. Now I want to write the complete ionic equation. The complete ionic equation says, once again, I'm going to go through And wherever I see AQ, I'm going to split it apart. But if we look at this is a precipitation reaction because remember, we're forming a solid. We have two aqueous solutions coming together to form a precipitate or solid. And when we do that, they're going to break apart, these aqueous solutions break apart into their individual ions to recombine to form this solid. So in the single displacement reactions, remember we only had like one aqueous solution on each side. Now there's a total of 3. We're going to break these apart into their ions, and their complete ionic equation would look like, we'd say, okay, I have one nickel that has a 3+ charge. Once again, I know it's 3 because there's a 3 here. When I was writing my formula, it's aqueous. Then I have 3 chlorides. It's a -1. I know that's -1 because chlorine's in group 7. It has a -1 charge anytime it forms an ion. Plus, I'm still breaking this apart. It has AQ next to it. I now have 3 potassium ions. The 3 potassium ions, potassium's in group 1. It has a +1 charge. I stick AQ next to it. And then plus 1 phosphate ion. The phosphate ion, we just have to know it's PO4 3-. An easy giveaway is that you had this formula K3PO4, so it must have been 3- to start with. And this is aqueous as well. Now, when I get to the product side, I see I formed this nickel 3-phosphate, which is a solid, meaning it does not break apart into its ions. It forms a solid, so I'm just going to leave that intact. And then when I get to this potassium chloride, once again, potassium's in group 1. It has a +1 charge. I want to break these apart as well because they are aqueous. And then I also have 3 chlorines or 3 chloride ions, -1, like this. So I have to remember to write the charge and how many of each ion I have. So this is the complete ionic equation. When I look at this, can anyone tell me what they think the spectator ions are going to be?
Yes, chlorine.
Chlorine.
3 chlorine.
Okay. Chlorine. So we see that we have 3 chlorides on both sides. Anything else?
The potassium.
Potash.
Potassium.
Yep. We see we got 3 potassiums on both sides.
That's
All
it.
right. All right. So great. You guys see this. These are my spectator ions. All right. So with that being said, I can now write my net ionic equation. And once again, remember the net ionic equation is just telling us what's really happening in this reaction. The only thing that's really happening is nickel ions are combining with phosphate ions to form a solid nickel 3-phosphate. So I'm just going to write that out. I'm just going to say nickel plus phosphate ions come together to form nickel 3-phosphate, which is a solid. And that's it. Now, like I said, this is a precipitation reaction. A precipitate was formed. You can do the same thing for gas evolution reaction. The only difference is instead of a precipitate or a solid being formed, you're going to form a gas and sometimes a liquid as well. And then if you have an acid-base reaction, you're going to form a liquid. Okay, and I have examples of that on the videos on YouTube. So if you guys are unsure of what I'm saying, just make sure you go back and watch the videos. So Do I have any questions on how I did this or what this means? So when we look at this double displacement reactions worksheet, this is really, if we were in person face to face, this was a lab. We would literally have aqueous solutions, like solutions of barium chloride and sodium sulfate in a bottle. We basically pipette a little bit of each one of them into a test tube and see the reaction that would occur. And then we'd write out the balanced equation, the complete ionic equation, and net ionic equation. But we are not, so I still put this online just so you guys can see and practice writing out the net ionic equation, the completed net ionic equations, and even practice writing out the balanced equations, because you guys get it when I'm doing it, but if you have to read the sentence, it's tough sometimes making sure you have the correct charge. So to make sure you get the correct charge, you're gonna need your periodic table. If you don't know your polyatomic ions off the charges, you're gonna need the polyatomic ion sheet. Make sure you're writing out these polyatomic ions correctly. Equations, doing the completed net ionic equations are pretty straightforward. All right, so do I need to do any practice problems on this worksheet, or do you guys get it? You think you get it?
I think I get it. If not,
Yeah.
I can always go back and review on YouTube.
Okay, cool, great. All right, so